Hello, everyone, and welcome back to your channel of Math and Engineering Made Easy. In today's session, I will go over the integration by substitution, which I never liked. I felt like it's like, making things not easy, but you are making it too convoluted. Things are much easier than that. In fact, in a previous session, I showed you in some instances, you have a function and you can, instead of integrating with respect to x, you can integrate with respect to a function of x. If you remember that. If you don't, please go and watch it. Today, I shouldn't be, I'm not saying I developed a new method. I just worked with some numbers and some functions and try to come up with an easy way. Of course, you cannot use this easy way in a calculus course if you want to show results. But if you are taking, say, a test, like a standardized test, where you only need to select, for example, one of the four answers, you can do it without substitution in a way I find easy to understand, and I will show it to you in different, like maybe 2 or 3 examples would be enough. We won't use substitution at all. So let's come up with an equation. By the way, I'm talking about definite integral, not indefinite, okay? It has to be. At least that's how I know how to do it. So this algorithm is quite simple. So it like skips some steps and take you to an equivalent integral that you can do without substitution. So let's take an example. I'm going to take like 2 simple examples. One of them, I will show you what I mean by that. Let's say, let's take an, I hate this one. Okay, maybe use that. A definite integral, let's say integration from whatever, 1 to 4 of some function. So I'm going to give you an easy function that most of you can integrate without substitution, but the idea is I'm going to show you my method that is pretty much equivalent. So let's have a function here of x, like let's say 3x minus 4 dx. Of course, pretty much everyone here knows how to integrate that without substitution. So this was like a trivial example. You would say 3x minus 4 square divided by 2, and you divide by 3, which is the multiplier of x. But I'm going to do it slightly differently. I'm going to say, okay, can I take the negative 4 out, throw it away, and make that equal to the integral of 3x dx? That's much easier to integrate. Not much easier, but simpler, right, to integrate. You would say, but they won't give you the same result unless you change the limits of integration. So you go back to the substitution. I say, wait, don't rush to conclusion. That's not what I'm going to do. I'm going to say, okay, that's exactly what we do in the substitution. Let's see if x is 1. I substitute with x equals 1. So you get 3 minus 4 is negative 1. And then I'm going to divide by the x coefficient. So 3 minus 4 is negative 1 over 3 is negative 1/3. And then I substitute the 4. 4 times 3 is 12. Minus 4 is 8. Divided by 3 is 8/3. These two are exactly equivalent. And you say, but I'm going to substitute with 1/3 and 8/3, so it's not that easy. I tell you, okay. The next step, so the first step, we got rid of the constant. Let me show you the result. I just made up this thing. So let's go to math integral. I'm going to integrate from 1 to 4. 3x minus 4 dx. And the result is 10.5. Let's try this one. So math 9 for integration. negative 1 over 3 to 8 over 3 of 3x dx. Hopefully I did it correctly. 10.5. And you say, no, I can make it even better. I can take the integral of x dx. So now nobody can tell me it's hard, right? X dx, so x squared over 2, right? But what do I do with this 3? Two things. First of all, I'm going to take 1/3. I take the reciprocal of the multiplier and then multiply the limits of integration by 3. So they are no longer fractions. Negative 1 to 8. Isn't that much easier? I didn't use substitution. I'm going to show you if we use substitution. So let's make sure, first of all, that this is the same. I'm going to say math. Oh, I'm sorry. I didn't want to do that. I want to take 1/3 times the integral from negative 1 to 8 of x dx. 10.5. What do you think? Nice? Instead of saying, so I can go from this to that in really 2 steps. The first step, I get rid of the constant, and then I multiply, so I will never end up with a fraction here. Excuse me. Now let's see what we would have done. As I said, most people know how to integrate that without substitution. That's fine. It's no big deal, right? However, most of the students would say, let u equals 3x minus 4. So du equals 3 dx. Or since I only have dx, I would say dx equals 1/3 du, correct? Some people take this integral, integrate it, and then return back to the x and use the same limits. Or others would say, okay, let me change the limits of integration. Guess what will happen when we change the limits of integration? You substitute 1, like we did. 3 minus 4 is negative 1. You substitute 4. 4 times 3 is 12, minus 4 is 8. And here is the 1/3. And here is u du, which is x dx. 1/3 dx. I'm sorry, 1/3 du. dx is 1/3 du, right? And you will end up with the same result. Let's take something else. So instead of being a linear function, let's make that, say, quadratic or a cubic. Let's take a cubic function. It doesn't matter. So I'm going to that's the, I'm sorry, I thought this was, okay, let's take the integral, say, of 3. Oh, no, let's make it 2x. This was minus, so make it plus 2 cube dx, say from 0 to 2. Again, you can do substitution the way I showed you. I do it in 2 steps while you can do it in a single step. You can take 1/2 because the 3 you took 1/3, and you just substitute the lower and upper limit. And I think that's much easier. I just do it on 2 steps to show you 3 different forms that are equivalent. I don't need to do that. The way I did it here, I said, okay, when I substitute with 0, I get 2 times 0 plus 2 is 2, and then I divide by the multiplier, so I get 1. And then when I substitute 2, 2 times 2 is 4, plus 2 is 6, and then I divide by 2, I get 3, and that would be 2x cubed dx. However, if we can go directly from here, I can say this is 1/2 because of the 2 integral of x cubed dx. And how do I get the limits of integration? I say 2 times 0 plus 2 is 2. 2 times 2 is 4, plus 2 is 6. Same thing. We can do it in a single step instead of 2 steps. I just wanted to show you, if you just want to get rid of the constant, you do it this way. But if you want to end up with x here, you can do it directly. Take 1 over that, substitute, and then multiply the limits by 2. This would be, I have 1/2 and x to the 4 over 4, so it would be x to the 4 over 8 from 2 to 6. Okay? If you substitute that, you get 6 to the 4th, right? So 6 to the 4 minus 2 to the 4 over 8. 6 to the 4 is 36 times 36, which is 1296, minus 16 over 8. It's 1280 over 8, right? It's 160. Let's do this and see. Integrate from 0 to 2, 2x plus 2 cubed dx. Yeah, good. I still can do math. Okay, maybe one last one so it won't be boring for you. But this time, let's pick something. Okay, let's do this. Let me take a function, let's say cosine, let's make it weird. 2x minus 5 dx going from 0 to pi over 2. Okay. Again, as I said, you don't have to do it on 2 steps, but I would say this is equal to cosine 2x dx. And the integral would be, I'm going to substitute the 0. I get 0 times 2 times 0 is 0 minus 5 is 5. And then I divide by 2. So negative 5/2. When I substitute pi over 2 times 2 is pi minus 5 divided by 2. It's pi minus 5 over 2. And then I said there is no reason for this middle step. I could divide 1/2 the integral of cosine x dx, but then the limits of integration, instead of dividing, I would multiply by. So I say 0 would give me negative 5, right? So I don't need to divide or multiply by anything. I meant you multiply those by 2. But if you're going directly, you just substitute what you have. Pi over 2 times 2 is pi, minus 5 is pi minus 5. And I claim that these 3 would give me the same result. We can check. Just want to make sure I am in radian. Yes, I am. Okay, so math. The first one, the integral is from 0 to pi over 2 cos 2x minus 5 dx. That would give me negative. Why negative? That's weird. Oh, yeah. Yeah, that's in radian. Okay, negative 0.9589. Let's do this one. Math 9. I'm going to take the integral from negative 2.5 to, between parentheses, pi minus 5 over 2 of cos 2x dx. Negative 0.9589. Oh, I should have moved it here. I'm sorry. Let's try the last one. 0.5, the 1/2, times math 9, integral from negative 5 to pi minus 5 of cos x dx. What do you think? I hope that was an easy way. As I said, if you are taking the course, you cannot go from here to there without explaining. So you have to use substitution. You have to say, okay, let u equals to x minus 5, and then work with the u and either change the limits of integration for u, or after you solve, you replace u back into x and use the same limits of integration. But if you are working on a high level course, you just do integration. In fact, most people would use the calculator. They won't bother to do it. But for some reason, if you want to simplify it so it can be easily checked, you can always reduce this function to x, just x. So it would be easy for you to integrate and maybe even find the answer without a calculator or a computer, if it's something like integer numbers squared or cubed. Okay, I hope that was a light session. May or may not help you. If it doesn't, I apologize for wasting your time. But if you like it, well, let me know by leaving me a comment in the comment section. And unless if you don't, then I just wish to see you soon. I will try to have more sessions in the coming days. I had some situations, so I didn't post anything in the past few days. I apologize for that, and I wish you all the best. Hope to see you soon.